morning, everyone,
Good
and
morning. Good
happy
morning.
Wednesday. We have today. Jafar just joined. So, hi,
Everyone.
Jafar.
Hi, Jafar.
Yeah, I had some
Just in
issues.
time to have a coffee with us.
Yeah.
Ah, just enjoying my espresso. It's very, very hot here in London. I don't know about you guys, but we are above 28, and in my apartment even more. So, so today we have for our OpenShift Coffee Break appointment, we have Gianni Salinetti
Good morning.
and of course our Jafar as co-host.
Hi,
How you
guys.
guys doing? Everything okay for today?
Yeah, that's okay. I have some noise in the house because I'm moving. I had just moved to a new house and I have people working inside and assembling my kitchen right now. So there's a bit of noise, but you know, moving house.
Yeah.
But anyway, everything is fine. So how are you?
Very, very good. Apart from the heat, that's the plague here in the UK as well. So everything is okay, guys. I know that you have a session packed of content for us. And so today you will be talking about Podman.
Yeah.
And I just wanted to ask you, I think you also recently came out with a book. What was it?
Yeah, exactly. We did a book. It's called Podman for DevOps, and it's been released by Pack Publishing more or less a couple of months ago in May, and was written by me and my super colleague Alessandro Arricchiello. He should have been here today, but unfortunately he had a small issue, so he could not join us. But he's with us with the force. So we wrote this book with purpose of providing a comprehensive book for Podman, not just to run basic stuff, but also uh, to understand and to manage complex scenarios, like, for example, security features, complex builds, and integration with systemd and Kubernetes, and so on. And obviously, how to manage a transition from Docker to Podman. So the book is going quite well, by the way. It's selling quite well. We're getting quite good feedbacks by people. So we are very happy. And by
And
the way, I'd like to
and the
thank
book is called Podman for DevOps, right?
Podman for DevOps. Yeah,
I'll
exactly.
send the link later for those that
Yeah,
are interested in.
absolutely. I also have one image with all the links in the presentation later. And by the way, I'd like to thank also other colleagues who helped us to provide technical review, and who are Nicola Amato, Marco Fagotto, and Pierluigi Rossi, who who were our technical reviewers. It's been some kind of Italian job because most of us were Italian. Uh, we had a very nice forward by Brent Bode. Brent Bode is one of the main developers, is one of the engineers working on Podman, along with Dan Walsh. And by the way, Dan Walsh gave us a great hand in writing this book. And he also getting out with another book about Podman. So be sure to check it out when it will be available. Dan Walsh is really the father of Podman, and so it's getting out with a book. So we're gonna have two books about Podman in the future.
Tell us a little bit more about yourself. What do you do? What's your background, if you wish, and what do you do for Red Hat?
Yeah, sure. Currently, I am a solution architect for Red Hat, and in the past, and I'm working especially. I'm more focused on cloud and infrastructure stuff, but also you have some DevOps background. And in the past, I've been an instructor, so I've working in training for Red Hat for almost 5 years. So this kind of experience teaching stuff to people has been a very huge part of my life, and still is. So I really love to share, to try to explain in a simple way things, basic or complex things.
Which is what we hope you're going to be doing for us today,
Yeah,
and take us in the world of Podman. So without further ado, because I'm conscious that we'll also have questions to answer, and hopefully we'll make it interactive. You prepared the presentation for us today, right?
Yeah, exactly. So I prepared this presentation along with Alessandro, and let me share with you. It was nice to call
And
it
it's
a
there,
coffee
so
with Podman. So
let me bring it to the streaming, and
yeah,
there you are. Take it
so I
away.
call it a coffee with Podman because it's the OpenShift Coffee Break. So it was nice to. So as you can see, we have both names, Alessandro, Arricchiello, and me. We have prepared this presentation together. We wanted to just grab the most important things from the book, and not to repeat ourselves about basic container topics, because I think that nowadays most of the people, most of our listeners, of our audience, is already aware of what containers are and how to start a basic container. But we wanted to focus more on details today. So the container history, how we get to Podman, from the history of the very first containers to Docker to Podman, an architectural deep dive of Podman, so how it works and how should I use Podman. Rootless containers. So let's talk about how we can run rootless containers in a more secure way with Podman, and let's talk about also about its companion tools. So Builder, to a very specific tool to build images, and Scorpio, which is a dedicated tool to manage images and registries. And finally, we want to introduce some more specific integrations. For example, how to integrate Podman with systemd. So how can we start containers as services inside a node? And how can we relate to previous technologies, Docker, like Docker Compose? Many people ask us, okay, Podman is great. It's very nice, but I have my Compose files. Can I use them? Okay, here we have the answers here. And finally, how to integrate with Kubernetes. So Podman is a native integration support and for Kubernetes, so it can generate Kubernetes manifests like pods and play those manifests. So we can provide to Podman a standard pod manifest, Kubernetes pod manifest, and have Podman run it for us. And this is a really a game changer for me. We'll discuss it later. And finally, we will provide some hints about interactive labs for people who want to try it out, and some further readings. By the way, also our books. So let's go.
Let's go.
Let's start with the container evolution. So we started everything at the dawn of the times. There was the chroot. So chroot in Unix was the first way to isolate a process, isolate in terms of file system access especially. Then the concept of chroot evolved over the time, and other operating systems like FreeBSD or Solaris provided other ways to isolate processes, like FreeBSD Jails or Solaris zones. The concept was quite similar. I want to isolate a process inside some kind of sandbox and have it only in there and not allow the process to escape its sandbox. This approach obviously reached Linux too, and it became available on Linux when the concept of namespace in the Linux kernel was introduced. The namespace in kernels are a feature that allows us to isolate a specific subsystem of kernels and create clones, so run processes in clones of a specific subsystem. For example, we can create a namespace, a network namespace, for example, and have a process run in a separated network stack. This is a great feature that allows us to trick a process and have it believe that it's running on a native host while it's running only in an isolated portion of the operating system. The first really usable implementation of containers leveraging namespaces and not only namespaces, also C groups, for example, was LXC. LXC is a container runtime which was implemented in the first years of 2008, and it was a very important step forward in container adoption. And the next step was the usage of an orchestrated version of LXC. So Red Hat published the OpenShift 2 in around 2011, and OpenShift 2 was using the basics of LXC containers. Then Docker came out. When Docker came out, it was a real game changer because Docker provided a way to use containers in a very simple way with an approach that was very familiar to developers. So what happened? Developers started to talk about containers, started using containers for their projects. And this adoption from developers was really the key to the evolution. This drove to other projects of orchestration, like, for example, Kubernetes. Kubernetes is still our main thing. We are talking about Kubernetes every day. And Kubernetes was born as an orchestration tool for containers running on top of Docker. Then it becomes something more evolved and provided more and more features, more and more API. But it was started as a project as an orchestration tool. And then obviously other projects like OpenShift OpenShift 3 were rebased on Kubernetes. So OpenShift 3 was a complete rewrite of code and completely different from OpenShift 2. For example, OpenShift 2 was written in Ruby and OpenShift 3 was written in Go. And it was based on Kubernetes technology. So we know the story of OpenShift right now, how it evolved, and it's continued to evolve on top of Kubernetes. Other things came out later because Red Hat acquired CoreOS, a company which provided the great sprint of evolution for container ecosystem. CoreOS developed many solutions like RKT, Racket, which is a container runtime, which was a container runtime, very interesting alternative to Docker. They developed Quay, and they developed the CoreOS operating system. When Red Hat acquired CoreOS, it adopted those technologies, and those technologies became a key to Red Hat evolution in a hybrid cloud and container world. So one of the things that came out after this evolution was Podman. Podman, we would see today, is a daemonless container engine, which has a lot in common with Docker, but evolves from the Docker paradigm of daemon-based container engine. So becoming a daemonless container engine based on basically on an approach on fork exec. Very simple to use. It allows the usage of containers in a rootless context, and it's very easy to implement and to adopt in complex scenarios. Along with Docker, with Podman, we saw other tools coming out, like for example, Builder and Cryo. We would see, and Scorpio. We will see them later. So that's a story of containers. And one last thing, during this evolution process, we saw a standardization of container technology. So Docker gave some of its code to the OCI Foundation. The OCI Foundation was a foundation funded also by Docker, by the way. It's contributed by many vendors, also Red Hat, and provides some standards, some standard specification to containers. So right now we are in a world that is more standardized than before, than in the beginning. And we have different specification from OCI, from runtimes, images, registries, and Podman obviously implements those specifications. So we have a fully standardized container engine. Some questions?
There didn't seem to be any question. Let's fast forward to today and see, what have we managed to do up to today, and so that we can see what the state of the art is.
Yeah, I would say so. Yeah, Gianni, thanks. It's always good to have those milestones reminded. But I think what would be interesting is because just be aware that we have 40 minutes left and it's gonna pass very quickly.
Yeah.
What are, I would say, the main? So I know one of the driving thoughts behind Podman was separation of concerns compared to Docker, for example.
Yeah, we see.
Can you elaborate a bit on that? Like explain how they dissected all the tooling we needed in specialized ones, and then maybe we can go a bit deeper into the details of what tools does what, etc.
We're just gonna, thank you, Jafar. We're just gonna take a look at the main differences right now. So we will focus on these three main topics: Podman, Builder, and Scorpio, and so some examples of them. And obviously, the main focus will be on Podman right now.
Okay.
So the transition from Podman to Docker was designed first to allow people using Docker to have a complete CLI compatibility with Docker. So people running Docker can start using Podman easily, and fully OCI compliance, as I said before. The main differences between the two container engines, they are engines, not runtimes. It's under the hood, and we will see what's the main differentiator between them. So first of all, let's start with Docker. Docker is daemon-based. So with Docker, we have a daemon running in the background, a system started by systemd that has the role of supervising the execution of all the containers, and not only the containers, as a role of orchestrating also all the other resources like network or volumes, for example, and also provides APIs. So our daemon in Docker provides REST APIs, and the Docker CLI is just a client which interacts with the REST APIs of Docker. We can expose those APIs using a Unix socket, which is the default, or using network connections. So we have a client-server architecture. Let's see in this next slide, which is basically very simple, but it's decoupled. In Podman, we have a completely different approach. We have a single object. We have a single container engine, which is not a daemon. It's a single Go binary that does all the job. So we can run Podman without any need of daemons in the background. And that's because Podman uses a fork exec model, fork exec approach. So it forks all the processes needed to run the container. So the command and the container run in a couple of slides. And also is implemented using a standard library, which is shared by other tools, like, for example, Cryo or like Beta. So that's very important because we have our use of code. Also, Podman introduced before Docker the feature of rootless containers. Later, Docker joined us in this feature and also introduced rootless containers. But in the very beginning, when Podman came out, it was a very interesting and new feature, the ability of standard users to run containers without root privileges. How? By mapping their user IDs to user IDs inside the container which have higher privileges. And this is achieved by using namespaces, user namespaces. And finally, Podman supports, as I said before, the OCI standard runtimes, image and storage specifications. Just like Docker, Docker also supports the standards. So this is a high overview, but I'd like to share with you some more details of how Podman runs its pods. So the basic thing is quite identical between how we run a container on Docker on Podman. As you can see, the only thing that changes in this example is just the name of the command, Docker or Podman. We have Docker run or Podman run. All the arguments and parameters are identical. And this is done, it was done on purpose because we wanted people adopting Podman from Docker feeling at home, feeling just like a drop-in, as a drop-in replacement. Many people create aliases like shell alias from Docker to Podman, or use the Podman Docker package to create a more complex alias and continue running the Docker command while running Podman under the hood. Maybe because they created their own pipelines and they don't want to change everything in their pipelines, and so just keep using the Docker command, but indeed they are using Podman. Other people are changing their pipelines or scripts and start using Podman command. But as you see, it's identical. What is changing is how Podman behaves under the hood. So let's see in a small architectural deep dive. As we said, we implement all the standards, not only the OCI standards, we also implement network standards like the CNI network, container network interface, which is a standard Kubernetes interface for networking. Nowadays, we also introduce a new network stack, which is written in Rust, which is called Network. And so we are very standardized with the community. And Podman, as we said, is only a container engine, which means that it has some kind of container runtime under the hood, which is responsible to run the container. The same things happens in Docker. Docker is a container engine and uses a container runtime under the hood. The default container runtime for Podman and Docker is runc, run container. Runc, by the way, was a project started by Docker and then donated to the community, to the OCI related community. And when the technology evolves and when the ecosystem of containers grows, other container runtimes appears. So we have, for example, now the C-run container runtime, which is a lightweight, faster container runtime written in C, not in Go. And we have other very interesting runtimes like Yuki, written in Rust. So Podman allows us, we will see it later, to swap container runtimes, to change the container runtime under the hood. What happens when we start a container? As we say, Podman uses a fork exec approach. So it means that when we run the Podman command, we are invoking the container engine. The container engine prepares the environment for us. So it manages networks, volumes, and so on, and then starts a process which is called conmon. Conmon stands for container monitor and is a process which runs detached from the main Podman process, and has the role of monitoring the status of the container. So when we run the Podman command exits with zero or non-zero code, while the conmon command process continues to run and continues to provide an interface to interact with the container. So if we restart a new Podman command on top of the container, we interact with the common process running. The common process, still following the fork exec model, runs the container runtime, which is run C or C run by default. And the container runtimes is responsible to execute at very low level the container. So it's responsible to manage the execution of the isolated process. It creates the namespaces, the kernel namespaces. It creates the process isolation in terms of resources, CPU and memory, using C groups. C groups are control groups for kernel, and a very nice way to isolate processes, to isolate resources for processes. So we can allow a specific amount of memory or CPU to a process. And the container runtime does this job for us in a transparent way. And we have the container up and running, the container runtime exits, and the process under the container is still monitored by the common process. As we said, the runtimes can change. We have many runtimes which can be adopted. We support with Podman the OCI runtime compliance. So we have runC, the runtime that is also used by Docker, and crun, as we said before, and other runtimes like Yuki, or for example, Kata containers. Kata containers are a very interesting runtime for executing containers in a virtualized sandbox. So you can try all these other runtimes by just swapping the runtime option in the Podman command. So if you want to change your runtime, you can pass the -- runtime option, specify the runtime path to the binary, and swap your runtime. And if you don't want to do it every time you run a container, you can specify the default runtime in the Podman configuration file. Any questions?
So, yeah, Gianni, just one quick question. Are there any known limitations for C run compared to run C, or are they at par in terms of features today?
No, they are quite similar. There are no limitations. By the way, C-run was introduced to overcome
Yeah.
run C limitation.
Yeah.
In the past, run C did not support C groups v2.
Groups. So, yeah.
Yeah, C groups v2 introduced a radical change in the hierarchy tree of the C groups of resources. So this change was not supported by runC in the beginning. So we introduced the crun from scratch to support C groups v2. And crun is even faster in terms of benchmark than runC. It's really faster and more lightweight. So yeah, sorry.
It's safe for use in production, or is it still experiment like?
It is safe for use in production. And by the way, with RHEL 9, it's still not default, but it's supported in RHEL 9 as a runtime for Podman. So it was a review, if I remember well, in RHEL 8 and in RHEL 9, but not the default, still not the default. but it's safe for runtime, for production use. Absolutely.
We actually have a question from the chat. Our GM is asking, what would be an ideal default container runtime if we use Podman for production? And I suppose the answer would be different whether we're talking about Podman standalone or if we're talking about a container runtime in OpenShift.
Yeah, it's different because when you have a container runtime running under OpenShift, we are not using Podman, but we are using Cryo. Cryo is another container runtime developed especially for Kubernetes. It's a container engine indeed, and uses the runc container runtime. It still uses runc container runtime.
And I think as you go down the presentation, we'll see the benefits of using Podman during your development. In conjunction with all the development tools and testing and all that. So I guess it will help when we get to that point to understand the differences.
Yeah, absolutely. By the way, when we have to orchestrate many containers, a complex scenario for containers, we usually need an orchestration tool, and that's why we go for Kubernetes or OpenShift when we need the orchestration plus many other features for developers and a platform for developers. Podman is great when we want to run a container in a single host or when we want to integrate with our development scenario. So Podman is great for DevOps context for developers. It's great for the integration with pipelines, for example. And in that case, I would go for C-run with no problem. But if developers, if teams want to adopt runc because they don't need to the feature of C-run, they can go for runc. Also, by the way, runc now supports cgroups v2. They introduced support, so they are completely swappable. So they can change between one and the other easily. So speaking of other interesting and important features of Podman, Podman introduced the concept of pod. That's why we have the name Podman. Podman stands for Pod Manager. So it's a container engine, but it does more than running simple containers. We can run containers inside pods. What is a pod? The concept of pod is a concept that was introduced with Kubernetes. And if you look at the official Kubernetes documentation, they say that a pod is a minimal execution unit inside Kubernetes. What does it mean? It means that a pod is a sandbox that can run one or more containers inside that sandbox inside the very same host. So we cannot have a pod split across two hosts, running a container in one host and a container in another host. The pod is a minimal execution unit inside one single host. And what does it mean under the hood to run a pod? It means that containers inside the pod share namespaces across them. Which namespaces? They share the network namespace, they share the inter-process communication IPC namespace, and optionally they can share the process namespace, which means that containers inside the same pod can communicate faster and easily, sharing the same resources, the same network resources. Maybe we don't always need to share network namespaces across containers. So when we do not need that, we do not need a pod. But a pod can be a very useful tool when we want to keep our containers together, running together on top of the same host. For example, for latency features to provide low latency of communication between pods, between containers inside the same pod. For example, let's see this example here. We created a WordPress pod and we put together inside the same pod a MySQL and a WordPress container running inside the same object. So we can migrate this pod in different nodes and be sure that the two containers will always be together. We use this approach in OpenShift to put together containers in the same pod that are expected to strictly communicate with each other. For example, reverse proxies on front of a container. That's what happens when we run service meshes inside a Kubernetes cluster. And we have, in that case, a reverse proxy inside in front of every container. And this reverse proxy, it's called Envoy, for example, for Istio, is running inside the same pod. And it shares the network namespace with the container. It means that the two containers will have a faster communication and will share the same network.
Gianni, one quick
Yes.
question about this, please. So, are you going to talk about the networking and how pods can communicate, etc. afterwards? Like if we have explaining the differences between like containers who are within the same pod, how they communicate, and if I split those two containers in two different pods and I want them to communicate, what are the different Podman networking options and how we can set them up and how they can communicate, etc. Like, just
Thank
to
you, Gianfranco.
lay some of the basic stuff.
Yeah, thank you. Very, very good question. Let's start from the end. So when we have two containers, two simple containers or two pods communicating with each other, we know that each container has a separate network namespace. So they act like separate hosts, and they need to communicate with each other. So we have to provide some kind of software-defined network to have them communicate. We have to provide layer 2 and layer 3 communication across them. The most simple way to do that is creating a Linux bridge and attach those containers to the Linux bridge. And that's exactly what Docker does since the beginning and what Podman does by default. So using a Linux bridge, we attach those containers and those containers can communicate at layer 2 and are configured on the same layer 3 IP network. And they're routed on the same network. So we have the routing rules, we have the layer 2 communication. So those containers can talk to each other in the same network, in the same layer 3 network, IP network. That's very simple. When we have two containers inside the same pod, those two containers have the very same IP address. So they are on the same network stack. It's just like having two processes running on the same machine and communicating in the same machine. Maybe on the loopback address on 17001. That's the main difference. As I said before, you do not always need to have containers sharing the same network. It's only needed when you don't want to use the software-defined network, or you don't want to bypass the software-defined network, and you just want to have strict communication between processes. By the way, the bridge networking is only the beginning. With Kubernetes, many software-defined network solutions were introduced. Kubernetes also standardized how networking should be done with a CNI, Container Network Interface. So what happens? All the network implementation for Kubernetes nowadays should be compliant with that interface, should implement that interface. So we have very basic solutions, like, for example, Flannel on Kubernetes, up to the most complex and obviously feature-rich solutions, like, for example, OVN Kubernetes, which is, by the way, used in OpenShift. OpenShift uses two possible approaches. The OpenShift SDN, which is based on OpenVSwitch, which is a virtual switch, an evolved virtual switch, which was created to overcome the limitations of Linux bridges and to create a decouplement between a control plane and data plane, which cannot be done with simple Linux bridges. And the evolution of OpenVSwitch was OVN, Open Virtual Network, a complete software-defined network which provides full control and decoupling on layer 2 and layer 3 too, not just on layer 2. So OVN was also introduced in Kubernetes, was implemented also for Kubernetes, and OpenShift adopted OVN as a new default, as a new standard for software-defined networking, since it provides a lot of features that allows us to create, to manage complex scenarios and to manage easily the isolations between containers and namespaces in Kubernetes and OpenShift, obviously. So,
Yeah. So, Jen, just for info, only 15 minutes left.
yeah.
I don't know how far we are in the preso.
Yeah, I'd like to move a bit faster if you agree.
Yeah,
I'd like to...
maybe there was a couple of things that we touched upon, like the benefits of running rootless containers from a
Exactly.
security standpoint. Maybe jump to that, and then move a little bit faster. I mean, obviously, like I said, we had too much material for today, so we need to move a little bit faster. Yes.
Yeah, absolutely. So I'd like to introduce now the concept of rootless containers. So let's go right straight to it. So what are the advantages of rootless containers? We run containers without root privileges. So we don't need to be root. We don't need to elevate our privileges to run those containers. And we provide a better isolation of processes. So a process inside a container which escapes the boundary of container in some way, maybe because of a security issue, maybe because of zero-day security issue, cannot escalate its privileges to become a root inside the machine. So we restrict the surface attack on the machine. And also we allow many users inside the same host to run containers without root privileges. And also we can provide a more secure way to manage our builds. This is very important. We can run bit pipelines as rootless containers, and we can also run our builds, like for example the build process or Podman build inside a container, so nested containers in a rootless scenario, which is very secure way to manage our builds without the risk of any kind of escalation. Speaking of builds, I like to also introduce you the concept of Builder. Builder is a native tool for managing builds, and by the way, Podman manages builds using the reusing Builder libraries, Builder code. So Builder also allows to make some more complex builds. We can use the basic, use it in a basic way. So run Builder to build from Docker files, as we know, or we can run more complex builds using Builder native commands. If you agree, I have a very quick example to show about this. So with this is, for example, an example to run Builder native commands. We can see that we have Builder specific commands that reflect the Docker file instructions. And so we can create a container from starting from an image, run our custom commands, and then finally commit our container and create a final running container. This is great, and it also, because it allows us to script and automate and put it inside a pipeline. So we have more control than a basic Docker file. We know that the Docker file has a, is a sequence of instructions. You cannot stop, pause that sequence, do something else, and then come back. And this is a huge limitation. With Builta, you can do the very same things of a Docker file, but you can also stop somewhere, do something else, and then come back. And for example, you can run comments inside Builta, then you can config and commit your image in the end. And this is a great game changer. And also, you can do builds from scratch. It means that you do not need to run a build from a base image. You can start from a scratch image, so from zero with an empty file system, and create your build from scratch, completely from scratch. Create your file system and build your custom image. This allows us to create minimal images, even distress images, which are great for microservices. We do not always need the huge Fedora image, the huge Debian image, or the even smaller UBI small or UBI micro image. Sometimes we really need a very essential minimal image, which should be 30 megabytes big, and you can do that in this way.
Okay.
The companion tool is Scorpio. Scorpio allows us to bring our images somewhere, to analyze our images, to push and pull our images from registries, and to manage our registries remotely. Scorpio, for example, can be used to inspect a remote image without pulling it. So we can pull the image with Podman locally and inspect the content of the image. But with Scorpio, we do not need to pull it. We can remotely inspect the image and see all the repository features, all its tags, and the image tags. And then just pull what we need if it's compliant with our needs. And also, we can use Scorpio to copy it from one registry to another. So we can do a remote copy between registries without pulling the image locally and pushing the image again remotely. And this is another great feature. Or we can use Scorpio to remotely delete images. And finally, I want to talk about the integration with systemd, Compose, and Kubernetes. So we can run our containers inside the Podman and allow them to be managed by systemd. Systemd can manage the execution of our Podman containers since, as we said before, we have a fork exec approach. So we can create containers of pods, generate our systemd configuration files, save this configuration inside a service, a unit file, a systemd unit file, and have it executed at boot of the system by systemd. So in that case, the execution is completely transparent for the user who doesn't know if the service is a native process or a container. An example that uses this approach with systemd and Podman is OpenStack. Red Hat OpenStack platform exactly uses this approach. So every service in Red Hat OpenStack platform is managed in this way. We have Podman in OpenStack running those containers, and all the containers are orchestrated with systemd. So we have systemd units for every OpenStack services, and it works very well. It works great, and it provided even a better way to manage OpenStack updates, which you probably know, it's quite complex. So what happens to people who need to adopt a Podman, but who still want to use their old Compose files to run a complete stack? They can still use them. They can use the old Docker Compose command. So they can install on Fedora the Docker Compose command and have it talk with the Podman REST APIs. So Podman doesn't use REST APIs by default, but if we have a client which needs to interact with REST APIs, we can start a REST API service using a systemd unit, a systemd socket unit. So we can start the Podman socket service unit, and expose REST APIs. And the Podman REST APIs are completely compatible with Docker REST APIs. So we can run the Docker Compose commands on top of Podman. If we do not want to use the Docker Compose command anymore, we have another alternative, which is called Podman Compose. It's very similar tool. They are both written in Python, and they are very similar in their behavior. So when using Podman Compose, we have a simpler way. We do not need to use the Podman socket because Podman Compose has a native interaction with Podman. One very important note: Docker Compose and Podman Compose are not supported on RHEL. They are supported on Fedora. Any questions?
And what is our recommendation? Or your recommendation, what they should be moving to instead of being stuck with Docker Compose?
That's a very good point. If we want to move on and use something which is more standardized on RHEL, we can use Kubernetes manifest. We can use pods. So we can generate pod manifest using the Podman generate cube. So run our Kubernetes containers or pods, generate our manifest, and then just play those manifests with the command Podman PlayCube. In our book, we have covered many examples for this because we really believe that this is the new way to manage complex stacks. So we covered basic commands using one single pod with many containers, and more complex scenarios using many pods interacting together on a dedicated network, which becomes a Kubernetes service, and also with dedicated volumes. So you can create more complex stacks. This command not only manages pods, but also services and volumes. So you can create, for example, speaking of WordPress, a complex stack which has different pods for Podman, for WordPress, for MySQL, and dedicated volumes, all talking on a dedicated service network, on a dedicated subnet provided by Podman. And this is transparent, very easy to do, and you can version all your files or your configuration YAMLs, and then quickly start a complex stack with Podman PlayCube command. This is our way to standardize, in my opinion. So people who want to keep using the Compose files are free to do that. But if you need something that is supported on RHEL and you need something that is more standardized with the new Kubernetes standard, which is some kind of unofficial standard nowadays, it's better to stick with this approach.
And so does it require Kubernetes on the machine, or it's just emulates?
Absolutely not. Absolutely not.
It's just manifests to create the...
Yeah, absolutely.
the containers, the networking, etc.
Because
I like
Podman
it.
itself can run pods
Yeah,
based on those definitions.
exactly. If you have a couple of minutes, I'd like to show you a very quick example just for this, just live.
Of course.
Sure.
All right. So I share this window here. Okay,
There you go.
There we go. So by the way, I'm running on top of Fedora CoreOS virtual machine. I say, why not using CoreOS? Fedora CoreOS is a Fedora distribution optimized for container workloads, which is, by the way, the distribution under the community version of OpenShift, OKD. OKD uses Fedora CoreOS as the basic operating system. We can use Fedora CoreOS standalone servers too, to run our workloads in containers. That's what I do usually. And I love its immutable approach. I love immutable operating systems. Here I already have Podman installed and everything else. And I just want to run this example. So I use a cut and paste to be faster. I'm gonna create a couple of volumes. They already exist because I have already tested this example. And I'm gonna create an empty pod called WordPress pod. This is gonna be a pod with 2 containers. Oh, sorry, it is Podman pod around WordPress. Let's do it from scratch. So if I do Podman pod, yes, I see this empty object, which has nothing inside right now. Okay, so now I create my containers inside my pod. So I create a container and I specify that it must belong to the WordPress pod with the --pod option. This is the MySQL container, and now I create the WordPress container in the very same way. Now I can start my pod, Podman pod start command. So I can see now that my pod is running, and I can see my 2 containers running, and along with the 2 containers, I see this object, which is called Podman Compose, which is a needed some kind of initiator container for the pod, which creates the sandbox and shares the network namespaces and the APC namespaces with the other 2. So I have my pod up running, and now I just want to generate a YAML file, a Kubernetes pod YAML. I can do it with this very simple command, podman generate cube. I give the name of the pod and I specify the name of the output file. So, sorry, file exists. I want to create it from scratch. And here we go. So now we have this YAML file, which is a Kubernetes pod, a standard Kubernetes pod. I automatically wrote all these annotations. I wrote down all the variables I specified and in a command line are inside my pod environment. And I have 2 containers, one container for WordPress and one container for the MySQL container. So I have everything I need. So now I can try to stop the previous container, the previous pod, and also remove it. Sorry, there is a typo. Podman pod. Sorry, it's not a pod. Sorry, there was a typo.
I
here.
think it's stop B.
Podman pod stop. Yes, and
Or-
Podman pod around WordPress. I will. So now I have completely removed the pod. There is nothing running, and I can run Podman PlayCube WordPress pod YAML. with the sync command, I recreate all the stack immediately. Now it's trying to pull the new image again. Probably it found the latest MySQL image, which is more recent. Obviously, this happens only the first time. And here we go. It created my pod and created the two containers. So I have the same result here. Podman, pod, PS, I have my pod running. Podman PS, I have my containers running. This is a basic scenario with just one pod, two containers in one pod, but we can create more complex and realistic scenarios like two pods connected to a dedicated network with a service. So it's great, it's fast, and it's very easy to use. And I personally prefer it to the standard Docker Compose approach. This is something personal, but I usually manage all my complex stacks in this way. So back to my presentation, to the final wrap-up. I'd like to suggest a couple of things. People who want to test Podman can do it in many ways. Can install the Podman binary. It's provided in almost every distribution. It's also available as a client with a Podman machine on macOS, so you can run Podman as a client and interact with a dedicated machine inside macOS. It's available in the Windows subsystem for Linux. And if you don't want any way to do it on your machine, you don't have a machine to test it, you cannot install it for some reason, you can use our interactive labs. Our interactive labs are available at developers.redhat.com, and we have some labs to learn how to manage containers, to get started, to manage container builds and registries, and we can do that. They are all based on Podman, and we can do them interactively without touching your laptop or machines. So they are great to experiment. We are safe to do anything we want in there. And also, we have other resources. So you can start by the Podman official documentation. For people who want to understand the code, see what happens, we have the GitHub repository, which also provides extra documentation, and the Podman blog, which is a very useful resource for updates and interesting topics. Different engineers from the community, like Dan Walsh or Brent Bolt, for example, they write there. And we have the communities. For example, we have the Discord community for Podman. So people who want to try Podman for the first time, want to learn, can join the Discord community, the Podman Discord community, and learn, ask questions, and believe me, they quickly answer to anything you ask. Me too, when I wrote the book, a couple of times I had some issues with the complex things I was experimenting, and I was helped every time on the community, on the Discord chat. So it's very active, it's very reactive, and be sure to join. And finally, if you want, you can grab our book for DevOps. And this is the cover. We have chosen some dolphins running the pod of dolphins, and Podman for DevOps is available on Amazon and part publishing. It is available as an ebook. It is available as a printed version. And you can also check out our GitHub repository for the book, which is the link you can see here, github.com, part publishing, Podman for DevOps, which provides some examples which are available, obviously, inside the book. We provided some example on GitHub for people who want to try them out. They are obviously available for anyone else, for example. So be sure to check it out, and also provide feedbacks. So thank you so much for time.
Thank you, Gianni, for the very informative presentation. And maybe and by the way, we do also talk about Podman when we talk about edge capabilities together with the Hackfest team. So this comes back in different shapes and forms during our presentations. I'm afraid that's all we have time for today. Jafar, any final comment, any questions?
No, I think it was great to have those insights. So thank you, Gianni. I will have a look at the GitHub examples as well, and I wish I could have the book for free.
Thank you so much. And by the way, Andrea.
Yes. No worries. We'll take care of that. Just wanted to wrap up and remind everybody that the next appointment with OpenShift Coffee Break is next Wednesday, the 20th of July, with our Database as a Service series. We'll be talking about Cockroach DB with Red Hat Open Database Access. And thank you very much, everybody, and goodbye.
Thank you so much for hosting me, for the time, and thank you. Goodbye.
Bye-bye. Have a good day. Bye-bye.
Have a good day.